Now let's take questions from the exercise of permutation combination. The first question, simple one. It says there are 6 candidates for 3 posts. In how many ways can the posts be filled? Very simple. First, there are only 3 posts, but there are candidates 6. So select 3 candidates out of the 6 candidates. So that can be done in 6 C3 ways. And then multiply it by the number of ways in which the 3 candidates can be arranged, the 3 selected candidates can be arranged over 3 posts. Now the arrangement can be done in 3 factorial ways. Alright. So if you calculate 6C3, it will be 6 into 5 into 4 divided by 3 into 2 into 1 into 3 factorial is 3 into 2 into 1. So 3 to 1 is cancelled and we will have 6 5s are 30 into 4, 120. Alright. Or the other way could have been, we could have gone post wise. So first post could have been filled in 6 ways because there were 6 candidates available for the first post. But then the second post, there are only 5 candidates available. Why? Because 1 candidate was used for the first post. Then for the third, there are only 4 ways available. Why? Because 2 candidates were used for first and second. So it will be equal to 6 into 5 into 4. That is 120 ways. So these are the 2 methods to do this question. Alright. Now second question. It says from among the 36 teachers in the school, 1 principal and 1 vice principal are to be appointed. In how many ways can this be done? Very simple. Out of 36, select 2 teachers, right? And then those 2 selected teachers should be arranged on 2 posts in 2 factorial ways. Okay, so select 2 people and arrange those 2 people in the 2 posts of principal and vice principal. Now 36C2 is 36 into 35 divided by 2 into 1 into 2 factorial is 2 into 1. So 2 and 1 cancelled. We'll have 36 into 35, that is 18 into 70, which is 1260. Or you can also have done like this, 2 posts, principal and vice principal. Principal can be filled in how many ways? Because there are 36 teachers, it can be filled in 36 ways. Then the second post of vice principal can be filled in by the remaining people, that is 35. So out of 35, only 1. So 35 ways. So the total number of ways would be 36 into 35, that is 1260. So these are the 2 ways in which these questions could have been done. Okay. Now the next question is a good one. It says there are 15 buses running between Delhi and Mumbai. In how many ways can a man go to Mumbai and return by a different bus? Alright. So there are 15 buses from Delhi to Mumbai. So let's go to Mumbai. First, let's go from Delhi to Mumbai. So Delhi to Mumbai, there are 15 buses. Select any one of them. Then multiply by the number of ways of coming back. Now while coming back, the one that he has used already will not be counted. So there are only 14 available. Out of that 14, select 1. Now 15C1 is 15, 14C1 is 14. So 15 into 14 is straight away equal to 210. Right? This is third question. Question number 4. It says the teacher of a class wants to set 1 question from each of 2 exercises in a book. If there are 15 and 12 questions in the 2 exercises respectively, then in how many ways can the 2 questions can be selected? Again, simple. There are in the first exercise, there are 15 questions and 1 question to be taken from that exercise. So 15C1 multiplied by the possibilities from the second exercise, which has 12 questions, and out of that select 1. So it is 15C1 into 12C1. So it is 15 into 12, which is equal to 180. So this also was a simple question. Question number 5. The students in a class are seated according to their marks in the previous examination. Once it so happens that 4 of the students got equal marks and therefore the same rank, to decide the seating arrangement, the teacher wants to write down all possible arrangements, one in each of separate bits of paper, in order to choose one of these by lots. How many bits of paper are required? Very simple. 4 people should be arranged in a line. 4 people arranged in a line. Right? So the number of pieces should be equal to number of ways of arrangement of 4 people in a line. Right? So number of paper bits required would be equal to the arrangement of 4 people in line, that is 4 factorial. Now 4 factorial is 4 into 3 into 2 into 1, which is 24 ways. That's it. So there are 24 bits of pieces are required. Now the next question, question number 6, it says, for a set of 5 true or false questions, no student has written all the correct answer and no two students have given the same sequence of answers. Alright. So if there are 5 questions and every question can be answered in 2 ways, that is true or false, right? So the first question can be answered in 2, what we are doing is we are trying to calculate total number of different ways to answer this question paper. That is equal to, for the first question there are 2 ways, then multiplied by second question, again there are 2 ways, third question 2 ways, fourth question 2 ways, fifth question 2 ways, right? Here we have to multiply because we have to answer, we have to attempt all questions, right? So this is equal to 2 raised to the power 5, which is 32 ways, right? So there are total 32 ways in this paper. Now this 32 ways includes a possibility in which all the questions have been answered correctly, but there is only one possibility wherein all the questions can be answered correctly. Alright, so the number, I'll just write number of ways to answer all questions correctly, right? Now first question, correct number of ways to answer correctly is 1, second is 1, third is 1, fourth is 1, fifth is 1, so it is 1 raised to the power 5, this is 1. So in this case where it says no student has written all correct answers, the remaining number of ways, remaining number of possibilities or number of ways would be equal to 32 minus 1, hence 31. So there are total 31 different ways under the given conditions in which the paper can be answered. That means the number of students, because no student has given the same answers, same sequence of answers, so the number of students has to be equal to the ways, number of ways in which the paper has been answered. So number of different ways to answer is 31. So the number of students is also 31. Now let's take the next question, question number 7. Read the question carefully. It says a code word is to consist 2 English alphabets followed by 2 distinct numbers between 1 and 9, including these numbers. For example, CA23 is a code word. How many such code words are there? So 1 place for letter, 1 place for letter, 1 place for digit and 1 place for digit. This is how it has to be done. We straight away do the calculation. The first 2 places are to be occupied by alphabets. So these 2 are to be occupied by alphabets. Alright. And these 2 are to be occupied by digits. Okay. So straight away we can say that the first place can be filled in how many ways? Now how many alphabets are there in the entire system? We have 26 alphabets. So first place can be filled in 26 ways. Then the second place can be filled in 25 ways. So multiply. Then the first place for digits can be filled in how many ways? 9 ways. Now why 25? Why this second place was filled in 25 ways? Because there were total 26 alphabets. One of them has been used in the first place. So second place can have, because we need distinct alphabets, so second place will have only 25 options. Similarly, in the digits case, first place can be filled in 9 ways because there are 9 digits. Then the second place can be filled in 8 ways. Why 8 ways? Because there are total 9 and one of the digits is used in that first place of digits. So the second place can be filled in only 8 ways. The total number will be 26 into 25 into 9 into 8. Now let's do one thing. Multiply 25 and 8, so it becomes 200. And multiply 26 and 9. Now 26 into 9 would be equal to 9 6 are 54. So 4, carry over 5, 9 2s are 27. 9 2s is, 9 2s is 18. Alright, so 9 6 are 54, 5 carry, 18 plus 5 is 23. So we have 23. So 200 into 234. So if you multiply, it will be 46800. Right? This is the answer of this question. Right? Now, there was one more way of doing the same question. Let's say like this. Other method for question number 7. How do we do that? See, these two places are to be filled by alphabets. These two places are to be filled by digits. Right? Now, let's do one thing. First, fill these two places. Now, for the alphabets, how many alphabets are available? There are total 26 available. Select two of them, so 26C2, and then arrange those two in these two places. Alright? Similarly, for these two places, we have to fill by digits only. Now, how many digits are there in all? 9. Select two of them and then arrange those two in those two places. Right? And then multiply the whole thing because we have to fill all four places together. You will get the same answer. You can check. 26C2 will be 26 into 25 by 2 into 1 into 2 factorial is 2 into 1 multiplied by 9C2 is 9 into 8 by 2 into 1 into 2 factorial is again 2 into 1. So 2 into 1 is cancelled here, 2 into 1 is cancelled here, and we have the same calculation 26 into 25 into 9 into 8, which obviously will come out to be 46,800. So whichever way you like, you can apply. Okay. Now let's take up the next question, question number 8. It says there are 6 multiple choice questions in an exam. How many sequences of answers are possible if the first 3 questions have 4 choices? Right? Now the first 3 questions, every question has 4 options. That means every question can be solved in 4 ways. So if there are 3 questions, the first 3 questions can be attempted in 4 into 4 into 4 ways. Then the next 3 questions each have 5 options. So each of them can be answered in 5 into 5 into 5 ways. So the total number of ways in which this paper can be answered is equal to 4 cube into 5 cube. Now it is 4 into 5 whole cube. This becomes easier to calculate. 20 cube is 8,000. Alright. So in this question, see, any question can be answered in as many ways as many there are choices. Right? So it is straight away 4 into 4 into 4 into 5 into 5 into 5. Now the 9th question. There are 6 multiple choice questions in an examination. How many sequences of answers are possible if the first 2 questions have 3 choices each, and the next 2 have 4 choices each, and the last 2 have 5 choices each? Same way, first question can be done in 2 ways. Second question can be done in 2 ways. Alright. One second. I'm so sorry. The first 2 questions have 3 choices each. So first 2 questions can be answered in 3 ways each, multiplied by. The next 2 questions have 4 choices each. So each of them can be answered in 4 and 4 ways. Then the next 2 questions have 5 choices each. So these 2 questions can be answered in 5 and 5 ways. Alright, so just multiply them. If you see, it is 3 into 3, that is 9. 4 into 4 is 16. Into 5 into 5 is 25. Now 25 into 4 is 100. 100 into 400. 4 into 9, 36. 100 is the total number of ways in which this paper can be answered. Alright. 10th question, it says each section in the first year of +2 courses has exactly 40 students. If there are 5 sections, in how many ways can a set of 4 student representative be selected, one from each section? Right? So there are 40 students in one section. Alright. And we need to select 4 student representatives, and there are 5 sections. One second. Please note that there is a correction here. There are only 4 sections. Alright, so 4 sections, only 4 sections, 40 students in each section, 40 students in each, and we need to select total 4 representatives, one from each section. Right? So the required number of ways is straight away equal to 40C1 from the first section into 40C1 from the second section into 40C1 from the third section and 40C1 from the fourth section, which is 40 into 40 into 40 into 40. Right? So 40 raised to the power 4. Now 4 raised to the power 4 is 256. So 40 raised to the power 4 would be 256 and 4 zeros. So this is the answer of this question. 25,60,000. Okay. Alright, so the total number of ways is 25,60,000. Please make the necessary correction. Okay, because there are only 4 sections. Now, let's take up the next question. Question number 11. Now, there are 5 letters and 5 directed envelopes. Find the number of ways in which the letters can be put into the envelopes so that all are not put in the directed envelopes. Now, please understand, if the letters are already directed or the envelopes are already connected to the letters, that means there can be only one way in which all of them can go into the directed envelopes or the correct envelopes. So, number of ways for all letters to go in directed envelopes would be equal to just one. There is only one way in which all of them can go to the pre-decided envelopes, right? Now, suppose we have to simply arrange, so let's count the total number of ways, right, to arrange 5 letters over 5 envelopes. That would be equal to simply 5 factorial. Now that is 5 into 4 into 3 into 2 into 1, that is 120. So there are 120 ways to juggle between the envelopes or to arrange all the letters over the envelopes, right? Now, out of these 120 ways, there is only one way in which all of them go into the correct envelope. Otherwise, rest every other way has a situation wherein at least one of them is wrong, right? That is the question asking. The question is asking in how many ways they can be put into the envelope so that all are not put in the directed envelope. So our answer of the question would be total number of ways, total number in general, minus all correct ways. Now all correct is just one way. So total number of ways is 120 minus 1, that is equal to 119. So there are total 119 ways in which the letters can be put into the envelopes so that not all are put in the directed envelopes. Okay. Now let's take question number 12. It says 3 horses H1, H2, H3 entered a field which has 7 portions marked P1, P2, P3, P4, P5, P6, P7. Alright. If no 2 horses are allowed to enter the same portion of the field, in how many ways can the horses graze the grass of the field? This is a direct question of selection and arrangement. There are total 7 portions. So select 3 out of 7 portions, that is 7C3. Then arrange the 3 horses on the selected 3 portions, and that can be done in 3 factorial ways. So it is 7C3 would be 7 into 6 into 5 divided by 3 into 2 into 1, that is 7C3 into 3 factorial is 3 into 2 into 1. So 3 to 1 cancels and we have 7 into 6 into 5, which is equal to 30 into 7, that is 210. So there are total 210 ways in which the horses can graze the field. Or the other ways like this, let's say there are 3 horses H1, H2 and H3 and there are 7 portions. Okay, we don't need to specify the portions. Let's look at H1. H1 has 7 ways to select a portion. Why? Because all of them are available. Now H2, when H2 goes, one portion is already occupied by H1. So H2 will have 6 ways. Now when H3 goes, 2 portions have been occupied by H1 and H2. That means H3 has only 5 ways. So the other method of doing this question is 7 into 6 into 5, which will give us the same answer, 210. So the thinking is slightly different. Alright. 13th question is almost same as this horse question. How many different numbers of 2 digits can be formed with the digits of 1, 2, 3, 4, 5 and 6, no digits being repeated? So basically what we are talking about, a situation here is, there are 2 places to be filled by digits. Now the first place can be filled by any one of those 6 digits, so 6 ways. The second place can be filled by only 5 of them. Why? Because one of the digits have been utilized. So the total number of possibilities would be 6 ways into 5 ways, that is 30 ways. So there are 30 such numbers possible. Alright. And the other method could have been, the same way 1, 2, 3, 4, 5, 6. There are 6 digits available and 2 places to be filled. So just select 2 out of 6. That can be done in 62 ways. Then arrange those 2 selected digits in these 2 places into 2 factorial. So 62 is 6 into 5, divide by 2 into 1. And 2 factorial is 2 into 1. So 2 and 1 cancel. We have 6 into 5, that is 30 ways. So 30 numbers are possible. Okay. Now let's take up the next question, question number 14. It says how many 3-digit odd numbers can be formed from the digits 1, 2, 3, 4, 5 and 6. And there are 2 cases. First case, repetition of digits is not allowed. So repetition not allowed. Alright. So we have to form 3-digit numbers and the last one has to be odd. So what we do is, in all such cases, we always start with the last place, that is odd or even. Okay. Now, if the last place has to be filled by if the last digit has to be odd, then look at the odd possibilities: 1, 3, and 5. So the last place can be filled in 3 ways. All right. So we have filled the last place in 3 ways. So one of the digits is gone. Why gone? Because repetition is not allowed. So we will not consider it further. So now there are remaining 5 digits. And there are 2 places. I repeat, there were total 6 digits. One of them is gone to the last place. Now, the first 2 places, they have 5 options. So first place can be filled in 5 ways. And the second place can be filled in 4 ways. Right? So the total number of ways will be 5 into 4 into 3. That is 60. So there are total 60 numbers for the first case. There is other way to do this. Suppose you fill the last place in odd way. So there are 3 ways to fill the last place. Now for the remaining 2 places, there are total 5 digits available. 5 digits available. So what we can also do is, we select 2 out of 5 and arrange in these 2 places. So for the first 2 places, the total number of ways will be 5c2 into 2 factorial. And for the last place, 3 ways. So you can calculate from here also. Now 5c2 is 5 into 4 upon 2 into 1 into 2 into 1 into 3. So 2 and 1 cancel. 5 4s are 20 into 3, that is 60. So there are total 60 numbers in the case of repetition not allowed. Right? So these are 2 methods that we have done. Now for the second question, second part of the question, that is repetition is allowed. So let's say repetition is allowed. Now the digits are the same: 1, 2, 3, 4, 5 and 6. And there are 3 places to be filled. Last place has to be filled by odd number, because the number has to be odd. Now for the number to be odd, last place has 3 ways to fill. Alright. Now the remaining 2 places, there are all 6 digits that are available. Why? Repetition is allowed. So even if the digits is used at the third place, can be used at the first and the second place. So now the first place can be filled in 6 ways. And the second place can be filled in again 6 ways, because repetition is allowed. So the total number of ways will be 6 into 6 into 3. So 6 is 36 into 3, 108. Right? So the answer of the question would be 60 for the first one and 108 for the second one. Alright. This is the answer of the question. Okay. Now let's take up the next question, question number 15. It says how many 2-digit odd numbers can be formed from the digits 1, 2, 3, 4, 5 and 8 if the repetition of digits is allowed. Alright. So there are 2 places that we have to fill. Now for this number to be odd, last place should be filled by odd number. So 1, 3 and 5. So these are the only 3 ways by which the last place can be filled. So the last place can be filled in 3 ways. Now there is only 1 place remaining and the repetition of digits is allowed. So all the digits can come. So there are total 1, 2, 3, 4, 5, 6 possibilities. So the first place can be filled in 6 ways. Alright. So the total number of ways would be 6 into 3, that is 18. So the total number of numbers is 18. That is the answer of the question. Okay. Then we come to 16th question. It says how many odd numbers less than 1000 can be formed using the digits 0, 2, 5, 7, and the repetition of digits is allowed. Now if the repetition of digits is allowed, then we don't have to worry about anything. The only thing that we have to be careful here is that less than 1000 there will be 3-digit numbers, there will be 2-digit numbers, and there will be 1-digit number. So digits available are 0, 2, 5, and 7. So first let's talk about 3-digit numbers. So how many 3-digit numbers can be formed? 3-digit numbers. Now for 3-digit numbers, the last place has to be odd because the question is asking the odd numbers. Okay, so the last place can be filled in how many ways? Only one way, because there is only one odd possibility, that is 5. So only one way. The remaining 2 places can be filled now because 0 is there. 0 cannot come in the first place. So the first place 0 cannot come. 2, 5, or 7, any one of them can come. So 3 ways for the first place, right? And for the second place, any one of the digits can come. So 4 ways for the second place. All right. So the total number of ways will be 3 into 4 into 1. That is 3 4s are 12. So 12 numbers can be formed. One second. There are 2 odd numbers. I'm so sorry. The last place has 2 ways, 5 or 7, because there are 2 odd numbers. So last place can be filled in 2 ways. So the total number of ways will be 3 into 4 into 2. Now 3 4s are 12 into 2 is 24. So total number of 3-digit numbers would be 24. All right. Now what about 2-digit numbers? Let's see. Similarly, 2-digit numbers and the numbers have to be odd. So last place can be filled in 2 ways, either 5 or 7. And the first place cannot be filled by 0. So 2, 5, or 7. So 3 ways. Right? So 3 into 2, that is equal to 6 numbers. And what about 1-digit numbers? So 1-digit numbers would be either 5 or 7, because we need odd. So just one, so 1 digit, so that means 2 ways. So there are only 2 numbers that can be formed. So total number of numbers that can be calculated as addition. So 24 plus 6 plus 2, that is 32 numbers can be formed. So the answer of this question would be 32 numbers can be formed. All right. Okay. Now question number 17. It says how many 3-digit numbers each less than 600 can be formed from the digits 1, 2, 3, 4, 5 and 9 if repetition of digits is allowed. All right. So we can do it here. 1, 2, 3, 4, 5 and 9. And we have to form 3-digit numbers. So 3 places. And repetition of digits is allowed. All right. Now see, if the number has to be less than 600, then the first digit has to be less than 6. Right. So 9 cannot come at the first place. 9 cannot come at the first place. That means the first place can be filled by any one of the 1, 2, 3, 4, 5. So 5 ways for the first number, first place. Now the second and third place are free because the repetition of digits is allowed. So second place can be filled in 6 ways and the third place can also be filled in 6 ways. All right. So it is 5 into 6 into 6, that is 30 into 6, 180. So answer of this question is 180 numbers that can be formed, which are 3-digit numbers and less than 600. Okay. Now next question, question number 18. It says how many words with or without meaning of 3 distinct English alphabets are there? Now there are total 26 alphabets available. Okay. And we have to form a 3-letter word, right? 3 distinct letter word. So there are 2 ways to do it. One way would be, let's fill the first place. It can be filled in 26 ways. Then the second place can be filled in 25 ways because one of them has been used. And the third place can be filled in 24 ways. So this is one way of doing this question. All right. So 26 into 25 into 24. Now 25 into 4 is 100. So 600 into 26, that will be 15,600 words that can be formed. This is one way of doing it. Now, or there is another way to look at this. There are total 3 places to be filled by 3 distinct alphabets. And there are total 26 alphabets available. So select 3 alphabets out of 26 and then arrange those 3 alphabets at these 3 places. Now 26C3 would be 26 into 25 into 24 divided by 3 into 2 into 1 into 3 into 2 into 1. So answer will be the same, 26 into 25 into 24, that is 15,600. All right, easy question. Now question number 19. Read the question carefully. How many numbers are there between 100 and 1000? Now any number between 100 and 1000 will be a 3-digit number, right? So we have to form a 3-digit number in which all the digits are distinct. In which all the digits are distinct. Now we know that the digits available are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are total 10 digits available. But the first place cannot be occupied by 0, because if the first place comes in 0, is occupied by 0, then the number won't be a 3-digit number. It will be a 2-digit number. All right. So the first place can be filled by without 0. Other than 0, all the possibilities. So there are 9 digits. So 9 ways for the first place. Right. Now for the second place, 0 is already been, 1 digit has been utilized as the first place. There were total 10 digits. For the second place, 9 ways are there. Now 0 can also come. Now for the third place, total 10 digits, 2 digits are gone at the first and the second place. So third place can be filled in 8 ways. Right? So total number of 3-digit numbers having all distinct digits would be 9 into 9 into 8. Now 9 into 9 is 81 and 81 into 8 would be 648. So there are total 648 numbers between 100 and 1000 which have all the digits distinct. Alright, now question number 20. It says how many integers between 1000 and 10,000. Now any number between 1000 and 10,000 would be a 4-digit number, and they should not have any digit other than 4, 5, 6. That means it should have only 4, 5 or 6. So 4, 5 and 6. Now nothing is mentioned. That means we'll assume that the digits can repeat. Alright, so they have digits, no digits other than 4, 5, 6. Okay, and there are 4 places. So we'll assume repetition is allowed. Okay, now first place can be filled by either 4 or by 5 or by 6. So 3 ways. Similarly, the second place, because there is no restriction, again 3 ways. Third place, again 3 ways. And fourth place, again 3 ways. Right? So if you multiply these 4 values, you will get the total number of numbers as 3 into 3 into 3 into 3, which is 81. So there are 81 such numbers. Okay. Now the next question is related to a question of a lock, numbered lock. Now it has 3 wheels, right? And those 3 wheels have 10 digits on them from 0 to 9, right? Now here, in spite of the fact that it is a 3-digit number, 0 can be used because we are talking about a physical lock. We are not just talking about a 3-digit number, all right? And in that situation, it says all the 3 digits are without any repetition, with no repeats, right? So here we can directly do it like this. The first place can be filled by all of any one of them. So there are total 10 digits from 0 to 9. Remember, 0 can also come here, right? So 0 can also come, that means 10 ways. I repeat, this is not just a 3-digit number, right? It is a 3-digit combination in which first place also can have 0, right? So first place can be filled in 10 ways. Now the second place, because the repetition is not allowed, can be filled in 9 ways. And the third place, because the repetition is not allowed, 2 digits are already used, so 8 ways. Alright, so total number of possibilities will be 10 into 9 into 8, that is 720 combinations. So 720 ways are possible. Or the other way could have been, we have all the numbers from 0 to 9 that are 10 digits and there are 3 places to be filled. So we select 3 out of 10 and then we arrange those 3 selected digits in 3 places. So it is 10C3 into 3 factorial. Now 10C3 would be 10, 9, 8 divided by 3, 2, 1 into 3, 2, 1. So 3 to 1 gets cancelled and 10 into 9 into 8 is 720. So there are total of 720 such combinations. Okay. Now let's take question number 22. It says a customer forgets a 4-digit code for an authentic automatic teller machine in a bank However, he remembers that his code consists of digit 3569. Find the largest possible number of trials necessary to obtain the correct code. Alright. So 3569 is are the digits, right? So basically the question is asking a 4-digit combination made by 3569. Alright. So we can straight away say that it is just a simple arrangement of these 4 digits at these 4 places. So the total number of possibilities will be 4 factorial, that is 4 into 3 into 2 into 1, which is 24. Right? So just 24 possibilities. Now we come to question number 23. It says n plus 2 factorial is equal to 2550 into n factorial. Now you see, n plus 2 factorial would be n plus 2 into n plus 1 into n factorial is equal to 2550 into n factorial. So n factorial and n factorial are cancelled. Now, if you look at this closely, n plus 2 into n plus 1 is a product of two consecutive integers. Let's try and break 2550, factorize 2550. If you divide by 50, you'll get 50 into, very nice, excellent, 50 into 51. So here n plus 2 is the larger one, n plus 1 is the smaller one. So write in that order 51 into 50. So very clearly we can see that n plus 2 is 51 or n plus 1 is 50. In any one of, from any one of them you will get n equal to 49. Or the otherwise you could have also factorized this or made a quadratic equation and solved, but that would have been a really difficult task. So better is to use this process, that better is to use factorization of this number. Okay. Now let's take the next question, question number 24. It says n plus 1 factorial is equal to 6 into n minus 1 factorial. Same process, n plus 1 factorial, if you open it, it will be n plus 1 into the next number, that is n, into, you can say, n minus 1 factorial, that is equal to 6 times n minus 1 factorial. So n minus 1 factorial gets cancelled. So we have n plus 1 into n is equal to 6. Now you can see 6 is very simply, now n plus 1 into n is a product of two consecutive integers. Now 6 can be written as 3 into 2. So very clearly we can see that n plus 1 is equal to 3, n is equal to 2. In any case, you get the value of n as 2. Right? Then comes question number 25. Let's see. It says n factorial upon 2 factorial into n minus 2 factorial and n factorial upon 4 factorial n minus 4 factorial are in the ratio 2:1. Find the value of n. Let me put it this way. N factorial divided by 2 factorial into n minus 2 factorial whole divided by n factorial upon 4 factorial into n minus 4 factorial. This ratio is given 2:1, or let's say it is 2 divided by 1. Okay, now n factorial and n factorial are cancelled. This denominator goes to the numerator, so it becomes 4 factorial into n minus 4 factorial. One second. So 4 factorial into n minus 4 factorial divided by 2 factorial into n minus 2 factorial, that is equal to 2/1. Right? Now I'll take it here. Now 4 factorial is 4 into 3 into 2 into 1 into n minus 4 factorial divided by 2 factorial is 2 into 1. Now very carefully open n minus 2 factorial. One second, I've written it wrong. The factorial sign should be outside. Now n minus 2 factorial, if you open it, first number is n minus 2. Then the next number will be 1 less than that, so that is n minus 3. And the next number would be n minus 4 onwards. So that means it will be n minus 4 factorial. Right? Now n minus 4 factorial and n minus 4 factorial will be cancelled. That is still equal to 2/1. Okay? From here 2 into 1 are cancelled. Now we have this 2 cancels 4 2 times. So we have 2 into 3, that is 6, equal to n minus 2 into n minus 3. Alright, as you can see, n minus 2 and n minus 3 are consecutive integers. So n minus 2 into n minus 3, and that is equal to 6. So break 6 to get 3 into 2 consecutive integers. Okay. So from here very clearly n minus 2 is equal to 3, or n minus 3 is equal to 2, because the larger one here should be equal to the larger one there. So in any case you get n equal to 5. So the value of n in this question is 5. Alright.